Assalamu alaikum, dear students. Hope by the grace of Almighty Allah, you are very well. Today, this is Muhammad Ashraful Azim, shortly AAZ, lecturer in statistics, Radhikatura Model College, is going to deliver a lecture on mathematics, especially algebra, chapter 4.2. This is for the students of class 6. Firstly, chapter 4, this is the part of algebra, and the name of chapter 4 is algebraic expression, and I will discuss the problem of 4.2, though this chapter is discussed in previous term, that is before half yearly examination, and the chapter is repeated in this term. That is why I am going to review the chapter. So, firstly, what is algebraic expression? You should know what is algebraic expression. According to the language of your textbook, firstly I would like to define or repeat the definition of algebraic expression. Later on, I would like to discuss about the topic algebraic expression. Here, it is written that the meaningful combination or arrangement of the numbers and operational signs are called the algebraic expression. Sorry. It must be a meaningful combination or arrangement of the numbers and operational signs. This is an algebraic expression. In another sense, I'd like to define the algebraic expression in such a way that it must be an expression of mathematical statement. If we express a mathematical statement by any literal symbol like A, it's a literal symbol, we must say it is an algebraic expression. But when it is 2 is not an algebraic expression. 2 is not an algebraic expression, but A is an algebraic expression. Again, when I want to say 2 plus 3, it's an expression, but it is not an algebraic expression. But if I say A plus 3, this is an algebraic expression because we expressed a sum where a little symbol is here. But though it's an expression, but in this expression there is no literal symbol. By this sense, an expression which contains the numbers and the operational sign, there must be an operational sign. Here you may say that A, is there any operational sign? Obviously there is an operational sign like 1 into A, 1 into A. Here this is an operational sign, this is a literal symbol, this is a numerical coefficient. So fully 1 into A equal to A, so we must say A is an algebraic expression. Here Ax plus B, it's an example of algebraic expression. A plus 2, it's an algebraic expression. Simply Z, it is an algebraic expression. So an algebraic expression can be expressed many ways. So we understood the algebraic expression. Since we are going to discuss 4.2 in the chapter multiplication rule of the indices, multiplication rule of the indices. Multiplication rule of the indices. This is a to the power m into a to the power n equal to a to the power n plus n. A to the power m into a to the power n equal to a to the power m plus n. This is called the multiplication rule of the indices. So, indices. This is the plural form of index. This is the plural form of index. Index means power. Power. Index means power. Its other name is exponent. So, power, exponent, index, order. These are similar terms. Index, power, exponent, order. These are similar terms. And the plural form of index is known as indices. What is index of power and what is base? You must know. A is square. Here A into A is in 2 times. Since there are 2 times, 1 and 1, so this is 2, and this is known as index or power, and this is called base. So this is base, this is power. In case of multiplication, if the base are same, then the power will be added, where m and n are natural numbers. A is not 0. In that moment, a to the power m plus a to the power n equal to a to the power m plus n. This process is called multiplication rule of the indices. I repeat, first you should know what is index. Since there is a term indices, we understood that indices is the plural form of index. What is index? This is nothing but the power. How can we get power? We also discussed in the previous class. Anyway, so we should know what is power, what is base. Now, multiplication rule of the indices. In case of multiplication, if the base are same, in that moment power will be added. So, a to the power m into a to the power n equal to a to the power m plus n. Now, dear students, if it is a to the power 3 into a to the power 5, it will be a to the power 3 plus 5, that is a to the power 8. Again, a to the power 5 into a to the power minus 2, a to the power 5 into a to the power minus 2. This is a to the power 5 plus minus 2. 5 plus minus 2, which is equal to a to the power 5 minus 2, that is a cube. So, this is the application of multiplication rule of the indices in algebra. On the other hand, a cube means a into a into a. A is written 3 times and three A's are multiplied. As a result, we get a product, and shortly we can write it a cube. Here the power is 3, so it is written as 3 times. Product of 3 A's equal to a cube. Now a to the power 2 into a cube, this is equal to a into a square means a into a, and a cube equal to a into a into a. Finally, this is a into a into a into a into a. There are 5 A's, so this is a to the power 5. But we can write this equal to a to the power 2 plus 3. This is a to the power 5. This is the multiplication rule of indices. That is a to the power m into a to the power n equal to a to the power m plus n. So dear students, this is about multiplication rule of indices. Now, in chapter 4.2, simplification, the first one, number 1, a, this is x cube into x to the power 7. Since we know the multiplication rule of indices, that is why we can write x to the power 3 plus 7, that is x to the power 10. Now, when this 2x cube into 3x to the power 7, like this, in that moment the solution will be 2 into 3 into x cube into x to the power 7, because 2x cube means 2 into x cube. So into 3x x to the power 7, this means 3 into x to the power 7. So it's separated 2 into 3 into x cube into x to the power 7. As a result, we get this is 6 x to the power 3 plus 7. This is 6 x to the power 10. Finally, the answer is, the required product is 6 x to the power 10. So this is the procedure of multiplication by using the multiplication rule of indices. Dear students, in number 2, find the value of each of the following expressions. Now, given number 2, in number 2, given a equal to 2, 2, b equal to 3, and c equal to 1. In chapter 4.2, in number 2, there are values of a, b and c, which are 2, 3 and 1 respectively. Now, using this value, we determine the values of some algebraic expressions. The first one is number 1, a cube plus b square. A cube plus b square. This is equal to what? A cube. A cube means a whole cube. It means a into a into a. Now this is 2 cube plus d square means 3 square. You may say that, sir, there is no bracket, but you write bracket. If you don't write 2 within the bracket, doesn't matter, but if the values a, b and c are negative, in that moment it is very, very essential to write the values within the bracket. That is, if a equal to minus 2, then if I say cube equal to minus 2 cube, this is wrong. We must write a cube equal to minus 2 whole cube. We must write a cube equal to minus 2 whole cube. But when the values are positive, in that moment it is not necessary to write the values within the bracket. But if the values are negative, in that moment we must write the values within the bracket. Now 2 cube. Since a cube means a into a, that is why 2 cube means 2 into 2 into 2, that is 2 to the 4, 4 to the 8, plus 3 square. 3 square means 3 into 3, so it will be 9. As a result, 8 plus 9 equal to 17, which is the required result, which is the required value of a cube plus b square when the values are a, b and c are 2, 3 and 1. Now, I hope that you will understood very clearly. Let us consider a equal to minus 1 and b equal to minus 2. A equal to minus 1 and b equal to minus 2. Now, a cube plus b cube equal to what? Dear students, if you write minus 1 cube plus minus 2 cube, in that moment it is wrong procedure. Your writing is not correct. So, what is the expression? How can we solve this? We have to solve such a way that minus 1, the value of a is minus 1. Its power is 3, so it will be whole cube. That means a cube. A means minus 1. I will say it is minus 1 whole cube. So this is minus a cube. A cube. That is minus 1 whole cube. So bracket is must. We must write within bracket the value within bracket when it is negative values. But if it is positive value, in that moment it is not necessary to write within bracket, but if you write within bracket, in that moment it is also correct. So a cube, this is minus 1 whole cube plus b cube, so it will be minus 2 whole cube. Now this is minus 1 plus, it is minus 8. How? Minus 1 whole cube means minus 1 into minus 1 into minus 1. That is, this portion is equal to plus 1 into minus 1. So finally, plus into minus equal to minus, 1 into 1 equal to 1. So minus 1 whole cube equal to minus 1. Similarly, minus 2 whole cube equal to minus 8. Now minus 1 plus into minus equal to minus 8, minus 1 minus 8 equal to minus 9. So finally, when the value of A and B are minus 1 and minus 2 respectively, in that moment the value of A cube plus B cube will be minus 9. That is the required answer. For example, when A equal to minus 1 and B equal to minus 2, then find the value of 2A square minus 3B to the power 4. Find the value of 2A square minus 3B to the power 4 when A equal to minus 1 and B equal to minus 2. Here, this is 2 minus 1 whole square minus 3 into minus 2 whole to the power 4. Now, this is 2 into 1 minus 3 into 16. This is 2 minus 48, which is equal to minus 46. That is the required answer. Yes, students, I would like to say, when the power or index are even ordered, in that moment the value must be positive, and if the order or power are odd, in that moment the value will be negative. I mean, here a cube, a cube, a to the power 5, a to the power 7, a to the power 9, and so on. A square, a to the power 4, a to the power 6, a to the power 8, a to the power 10, and so on. I want to say a to the power 1 and a, these are similar. A to the power 1, a to the power 1, a to the power 2, a to the power 3, a to the power 4, a to the power 5, a to the power 6, a to the power 7, a to the power 8, a to the power 9, a to the power 10, and so on. Here the power are odd, and in the below you see that the power or index of A are even. Perceive that when the base are negative and the power is odd, in that moment the value is always negative. And if the base are negative and the power is even, in that moment the value will get always positive. That is, their values always positive and their values always negative when the base are negative. But if the base are positive, in all cases we get the positive value. I repeat, if the base are positive, in all cases we get the positive values, and if the base are negative, in that moment the values will be positive or negative, depends on the base. So when the depends on the order of power. When the power or exponent or index are odd and the base are negative, in that moment their values will be negative. And if the base are negative and the power or index are even, in that moment the value always positive. There is another point, which is a to the power 0 equal to 1. Something to the power 0 equal to 1. like we said that a cube, sorry, a to the power m into a to the power n equal to the power m plus n. That is, in case of multiplication, if the base is same, in that moment the power will be added. But in case of division, if the base is same, in that moment power will be subtracted. In case of division, if the base is same, in that moment power will be subtracted. And in case of multiplication, if the base is same, in that moment power will be added. So a to the power 0 equal to 1. Sometimes a short question, that is in MCQ, the question may be asked that a to the power 0 equal to what? The options are 0, number B 1, number C A, number D none. That type of question may be asked. So sometimes if you don't know, in that moment you may answer this. But no, this is wrong. The correct answer is B to the power B. That is, the answer is 1. How? First, a square divided by a square equal to a square divided by a square equal to a into a divided by a into a equal to 1. Simply, when the dividend and divisor are same, I repeat, if the dividend and divisor are same, then the quotient is 1. And this is the explanation. We get a square divided by a square equal to 1. But if we apply the division rule of indices, in that moment we get a square divided by a square equal to a to the power 2 minus 2 equal to a to the power 0. So we get a to the power 2 divided by a to the power 2 equal to a to the power 0. On the other hand, a square divided by a square equal to 1. That is, a to the power 0 equal to 1. I said that in case of division, if base is same, in that moment power will be subtracted. On the other hand, we know that if the dividend and divisor are same, their quotient will be 1. So here, a square divided by a square, applying the division rule of indices, we get it is a to the power 0. On the other hand, a square divided by a square, after calculation we get 1. So it is equal to 0 equal to 1. So dear students, I'd like to explain the key points of the chapter deeply, and in this lecture mainly the basics are repeated. There are a lot of information, and step by step in my different classes I will try my level best to deliver by my lecture. And since in the previous term, that is in half yearly exam, the chapter was in your syllabus, that is why the problem of the chapter you can solve. But since this chapter is repeated in your annual examination, that is why I again repeated the basic of the chapter. And in the next class, anyway, I would like to solve a problem. After that, I would like to complete today's class. Number 3. Given x equal to 3, y equal to 5 and z equal to 2. We have to prove number 1, y square minus x square, left hand side y square minus x square, that is y means 5 minus x means 3, so this is 25 minus 9, that is 60. Again the right side will get x plus y into y minus x plus y into y minus x. This is 3 plus 5 into y means 5 minus 3, that is 8 into 2, that is 60. So the left hand side, the value of the left hand side is 16 and the value of the right side is 16. That is why left side equal to right side, so it's proved. Therefore left hand side equal to right hand side, so y square minus x square equal to x plus y into y minus x, and hence it is proved. But you will write this portion in the below side. So my beloved students, by the system we will solve the problems of the chapter, and in next class I will solve the creative question and some important questions of the chapter. So no more today. Thank you very much. Allah Hafiz.